Afternoon, people. It's going to take a minute or two for all the attendees to come in, so we'll give them a bit of time. Welcome. Today's presentation is called Becoming a Deep Learning and Generative AI Engineer with NVIDIA and Excel ILT. We're expecting a very large group, so we're going to run this very much webinar style. That means you won't have video, and it's only one-way audio. You'll be listening to myself for a little bit, and then Mike is your main presenter. But you will be able to ask questions. I think we have both a QA and a chat. Let's just use the chat. So if you have any questions, you can put them in the chat. Maybe while we're waiting for the rest of the people to come in, just maybe let us know where you're coming from. So in the chat, you should see hello from Toronto, which is where I am. Maybe let us know where you're coming in from. That's usually good to know. The attendees are up near 100, so we'll oh, there, in Miami, Virginia, California, all over the place. Quito, Ecuador. Excellent. All right, well, it's still going up, but we'll get started. Today's presentation is on becoming a generative AI engineer, and we will be sort of showcasing some courses that, from NVIDIA. This presentation is put on by Excel ILT. You may not be familiar with that name. It's sort of an umbrella brand of Accelerate, ExitCertified, and WebH Solutions. So these are three training companies been in business for a long time that have come together under one umbrella. And each has sort of a slightly different focus. At ExitCertified, which is where I come from, we've been focused more on vendor authorized courses from 25 plus vendors. And one of our newest vendors is NVIDIA. And so that's sort of what we're teeing up here today, is to talk about the journey to becoming a generative AI engineer. NVIDIA has some really great courses, and Mike will tell you a little bit about those. He'll tell you a little bit about generative AI in general, but also what are the skills needed to get there. And, even before you can get into the NVIDIA classes, you have to kind of know Python and some Python packages. And so we actually have some pretty good training that WebH has built for getting upskilled on those kinds of skills around the Python side of things. And so I'll introduce Mike, and then I'll let him take over. Mike's been 20 plus years in IT with an emphasis on building big data and ML pipelines, both in the public and private sectors. He is an NVIDIA certified instructor. He teaches a few of the classes that we'll highlight at the end. We actually have some dates coming up in February that we'll mention. And he also, for us, teaches AWS and Google Cloud. He's been certified in all sorts of things, but most importantly on this side of things, he's got the AWS machine learning and the data analytics and the Google Cloud data side of things. And Mike is a really great instructor. We're really glad to have him here. We'll throw his email address, and I'll put mine in as well into the chat, so that if you have questions after the course, you want to keep asking, you can do so. We'll also give you some next steps of where to go from there. So Mike, if you want to take over, anything else to say about yourself or your experience?
No, thank you. Thanks, Miles. And thank you all for attending this webinar. Again, my name is Mike Bitar, and hopefully by the end of this webinar, you will have a good understanding of the offers, educational offers, and the timeline, as well as the roadmap that are involved in this roadmap. So the agenda for this webinar, first we're going to discuss the power of generative AI. I think most of you are here because you do have an understanding of the impact of generative AI. It's been in the news. It's been growing rapidly over the last year or so. It's nothing short of miraculous, the sort of developments and all the academic paper and all the models and all the demos, from music generation to image generation to video generation to advanced chat bots and so on and so forth. But to get to generative AI, of course, you still have to establish some sort of a a solid foundation in classical ML. And classical ML today, ironically, also involves neural networks and convolutional networks and deep neural networks. Just a year or so ago, the neural networks were considered the leading edge. Now we are moving to a higher level of abstraction, with the arrival of generative AI. Now, when we talk about generative AI, sometimes folks assume that it's strictly, LLMs. Other folks assume it's, text to image, or we're actually going to try to cover primarily both, text-oriented generative AI, as well as, image or multimedia-oriented generative AI. And NVIDIA's offerings actually support both categories. Things might change a year or two from now, but right now, it's really primarily those two technologies that form, most of the news headlines that we see in the media about, the power of generative AI. So we're going to discuss key skills for a generative AI engineer, and which workshops can help you attain those skills. And towards the end, we're going to have a Q&A. And in between, we might have a couple of quick demos, quick walkthroughs. Now, throughout this workshop, I've actually, since this is about generative AI, I have interspersed text to image, artwork. Might as well, right? So if you know Sir Arthur C. Clarke, and he's the co-author of the 2001 Space Odyssey movie. If you're in my age group, this is an awesome movie. It's like Matrix for the younger folks, and The Expanse for the even younger folks. But yeah, so he said any sufficiently advanced technology is indistinguishable from magic. And I don't know about you, but since the arrival of ChatGPT and other LLMs to the scene, and text to video, text to image, text to video, it is almost magic. I mean, it's unbelievable the kind of things that you can do today, even with open source / free tools. And everyone now wants a piece of the pie. So let's, in terms of employers wanting their employees to upskill, in terms of workers in the workforce who wants to stay ahead of these developments. So hopefully by the end of this webinar, you will have a roadmap to get from point A to point B. Next. So just starting with an icebreaker here. So before I put together the slide, literally just last night, I decided to, like I said, just go to a tool called Comfy AI, which exposes the parameters for Stability AI Stable Diffusion model. And if you've worked with DALL-E, or if you worked with Imagen or some of the other text to image, then you've seen how fascinating these tools can be. And these are really images that were generated without much tweaking. So prompt was abstract, futuristic backpack design. Again, bam, just kept clicking generate, and just picked 4 at random. Really impressive, right? Let's look at the next slide. Same thing here. Again, I just typed abstract, futuristic table lamp design, powerful light casting shadows, and it generated a bunch of images. And if you didn't know there is something called text to image or diffusion models or whatever, you would think those are real world photographs that someone took a camera, pointed it at these lamps, and took a snapshot and uploaded to a website. But these really may or may not exist. For all we know, they are completely 100% sci-fi lamps that don't exist in reality. Next. Same thing. So now we're switching gears from text to image to, let's say, large language models. And in this case, we passed this review to one of the popular, chat AIs, and we asked it to perform sentiment analysis on this review. And again, the review is a bit cynical, right? I mean, it's sort of like it complements the product, but at the same time, it's sort of like it takes a couple of digs at it. And, if you are a company where you have, thousands and thousands of customer comments and customer reviews, sometimes it's not just practical to have persons go through all those comments and basically, assess them, and provide like some sort of a score. So with the use of tools like large language models, now you can automate the process. The process is now simpler. Sure, we had tools before that actually could perform sentiment analysis, but now, we have tools that we don't really even have to train. We can to make it more specialized, but many of these tools are generic, but are based on massive data sets. Massive data sets, to the point where some of them actually can perform general jobs perfectly without you having to basically refine those models. Next. So here the model comes back, and as you can see, I've truncated the response. The response was quite sophisticated, and yes, it used these bullets formats, and it was actually a couple of screens long, and it was impressive. Now I could have just programmatically literally just sent an API call to the LLM saying, hey, from 1 to 10, how do you rate this? What's the sentiment of this comment? And again, it would have responded with a score, and I could have captured that score and then performed processing. And this is how you get, the LLMs to work for you at scale. Next, please. Again, another example. I uploaded artwork by Gustav Klimt. It's a very popular painting of his. And I asked the LLM to analyze this image. And if you look at it, this looks like, I'm no art critic, but this actually, to me, this actually looks quite impressive, the description, the details. And every time I tell it, give me a different analysis, it would actually generate a completely different, set of, text that's eloquent, that's well-structured, that's, that actually does justice to this painting. And this is just, you can call this first or second generation LLMs. I mean, this is barely the first year anniversary of, let's say, the more popular, chat LLM, which is, I think 3.5 was the one that, sort of like, started all this buzz. And then it's been downhill from there or uphill from there. So yeah, so a year or two from now, who knows how powerful these LLMs can be in analyzing images. Maybe they can analyze, blueprints, design patterns, patent, blueprints. You never know what's coming basically down around the corner. Next, please. So, generative AI. I think we're here because some of us are curious. Some of us are curious, a bit worried. Some of us basically just would like to see where things are and maybe how to put together some sort of a plan, a career plan that helps you upskill, so you are ready for the next generative AI era. So based on some surveys, and those change all the time, by the way, over 10% of tech job postings now seek AI expertise. If you go to Glassdoor or LinkedIn or some of the other job boards, and if you just basically enter, machine learning, AI, or some of those keywords, you can do actually quite a quick survey, and you will notice that every month the percentage of jobs that involve in one shape or form, AI/ML skills is actually increasing quite rapidly. About 37% of bosses used AI to replace workers in 2023. Not a good stat, but it is happening. Whether these numbers have peaked or they will continue to rise, we don't know. Okay, over 29% of employees fear their job are next. Yeah, me too. So, instead of working in consulting, I moved to teaching. So this way, I'm accelerating the process of being replaced by AI. Soon, my deep fake will be delivering these webinars. I hope not at the near future. And around 20% of U.S. jobs, or 50 million roles, could be automated by 2030. This is a McKinsey Global Institute study that sort of like unsettled, many bosses and many corporations. And whether it becomes a self-fulfilling prophecy, whether it's a real change, we will start seeing the impact of AI, in 2024 and beyond. Okay, next, please. And Miles, please feel free to interject with comments if you have something to add. So, what is generative AI? So again, AI is an umbrella term today, and it encompasses all of the subfield or the specializations such as machine learning, deep learning, and generative AI. And we are seeing, by the way, that as we move from one layer to the other, the level of abstraction is basically moving higher and higher. With classic ML, you actually were involved in the nitty-gritty aspect, every aspect of machine learning, from pre-processing, data munging, data collection, subsetting, to model selection, to training, evaluating, deploying, and for better or for worse, we had to become experts in each aspect of the ML pipeline state. DL took it a step higher. Now we have neural networks, including convolutional neural networks or deep neural networks, and we started, using tools like, TensorFlow and PyTorch with their libraries. Again, that moved the level of abstraction a little bit higher. With generative AI, this level of abstraction has even moved higher and higher. So now we are actually working with already trained models and already existing and mature AI architecture or neural networks. And what we're doing now is building pipelines of these networks. So while in the previous stages of AI, we were actually, the whole application or the whole solution can be based on a single model or a single architecture. Now we are actually using ensembles of solutions, of network architectures, such as in LLMs and in Stable Diffusion and others, to basically produce the desired outcome, whether it's text to speech, whether it's text to image, whether it's text to text generation, and so on and so forth. So what can generative AI generate? I think, again, most of you are familiar with this. And again, all of these images, by the way, were generated with Stable Diffusion models using Comfy AI, but you could have used any tool, including Python. So summarize and analyze content. And yes, by the way, I rely heavily today, personally speaking, I rely heavily on my collection of LLMs to do my work on a daily basis. And it's an amazing time saver. Yes, it does require, supervision. If I don't know what I'm doing, it's going to be garbage in, garbage out. So summarizing, analyzing, sometimes I don't have time to read a whole paper, academic paper. So I ask my favorite LLMs to summarize it, and I basically just extract what's meaningful to me. It can write poetry, believe it or not. It does a decent job. I'm sure most of you have already tinkered with those capabilities. Generate images, and those images are becoming incredibly amazing. And yes, now we're actually moving into text to video generation, and we're seeing tools that can generate maybe 5 or 10 seconds of I can't call it realistic video, but it's abstract, if you want to call it this way, but it's still impressive. Okay, but the pace of progress is quite significant. So not surprised if in a couple of years someone can sit down and basically type a prompt that says, hey, generate a training video for generative AI. Yeah, that would be the end of my career right there. Generate an audit code. I think again, it's no secret that the code assist capabilities of some of those LLMs is quite impressive. Whether you're using ChatGPT-4 or Microsoft Copilot or Bard or some of the other tools, that capability is actually maturing quite rapidly. Compile reports. You can feed some of those LLMs tabular data, and it can generate reports, meaningful reports using English language, for example, and it can generate graphs, charts, you name it, and it can perform quiet, accurate analysis on tabular data. Okay, especially if you're dealing, let's say, with tools like Chat GPT 4.0, with its number crunching capabilities. It does translation, and of course makes music, and some of the music that I've heard that was generated by AI is actually quite convincing. So yeah, interesting times ahead. So almost all of these actually are divided between those two models we talked about, the LLM architecture and the stable diffusion. But that might change literally a few months down the line. Why all of a sudden? I mean, generative AI existed for years. I mean, when you were talking to Alexa or Siri, there were many, many AI models and AI solutions that generated content. But it was never as powerful. It was never as flexible. It was never as human-like as some of the generative AI models that we're dealing with today, from ChatGPT, Bard, Copilot, and the others. So what happened? Well, a number of things happened, and the key developments is, of course, the presence of massive data sets. And we're talking massive, we're talking terabytes, in some cases petabytes, and in the future we will see exabyte scale data sets. And some of those data sets are open source for anyone to download and use to teach their models. Others are proprietary or commercially available. That means you have to pay. Some of them you may not be able to access except through APIs, if at all, like ChatGPT 4 and beyond. And of course, the internet made it possible to capture human interactions in many media. Whether it's Twitter or Facebook or Wikipedia or Stack Overflow. So the internet actually was just a natural living data set that many LLMs actually and text-to-image models have based their training on. And those are some of the most ideal actually data sets for LLMs, because they are based on typical human interaction, if there's such a thing. And then, of course, compute power. So today we have cheaper, and again, it's all relative. I mean, an NVIDIA A100 GPU is not exactly cheap. I mean, we're talking about thousands of dollars. But the power that you have available at your disposal, either by acquiring this hardware directly or by basically using it in an on-demand model from, let's say, a cloud provider. I can log into AWS today, and I can basically provision an NVIDIA GPU-based virtual machine, and I can do training, hour, 2 hours, 3 hours, shut down that virtual machine and only pay for just the 3 hours that I've used this virtual machine. So I don't have to basically fork out tens of thousands of dollars for GPUs to train. So if I'm a startup, I don't have to make that commitment upfront. And that brings us to the IT infrastructure. And today, the cloud is also a key element or a key factor in accelerating the growth of generative AI, just because any startup, any company, any person can have at their disposal a massive amount of compute, storage, and network resources, and again, using the on-demand pay-as-you-go model. Next, please. Massive open source or commercial data sets. So what are some of the data sets that are available for today's LLMs? Well, in addition to some of the private, closed or commercially available data sets, you have the more popular ones that most of us or most companies can have access to, such as Book Corpus, the Pile, Common Crawl. I think it's the Wikipedia, unless I'm confusing. I think it's the Wikipedia data set, C4, and so on and so forth. And if you look at those sizes, by the way, like Book Corpus is a 2.7 terabyte. I think this has like a capture of, I don't know how many tens of thousands of books. There are some licensing issues with this data sets, nevertheless. But if you look at the Pile, look at the size of, So unless you have access to, if you're a startup, unless you have access to stores like S3 or GCP's equivalent or Azure's equivalent, that's going to be quite expensive, to provision this amount of storage in-house. Okay, next, please. Okay. Same thing on the compute side. So on the compute side, NVIDIA today, without a doubt, is probably, I would say, the leading force in AI training infrastructure. So most of the, not all, but most of the LLMs and stable diffusion models have been trained on NVIDIA hardware. And most of that hardware is licensed or rented from cloud providers, but some actually have their own in-house data centers. Not too many, but For example, Stability AI Stable Diffusion was trained, at least last time I checked, on a fleet of GPU accelerated EC2 instances on AWS. Same thing for ChatGPT. Google has its own, tensor infrastructure, and they're manufacturing, they're fabricating their own chips now. But yeah, same thing for Azure. So if you look at the progression of NVIDIA's GPU capabilities, now when NVIDIA started making cards, most of us remember, those were basically for gaming. Then maybe for CAD and, maybe for like video editing and so on and so forth, or video rendering for 3D applications. And if you look at the factor by which the capabilities of those GPUs have increased over time, it's quite substantial. Transistor count, in 2002, the GeForce 5800 had 125 million transistors, but today, the GeForce RTX 4090 has 76 billion transistors. Core count, same thing. Clock speeds, dramatic increases. Memory capacity, of course, we can't take each metric by itself. We have to look at all of these metrics to basically get a feel of the massive amount of performance improvement over the years with these GPUs. AMD, can tell you a similar stories, and now Intel is getting into the game and so on. Next, please. So on-demand elastic IT infrastructure, the cloud. So now, using, your favorite cloud provider, GCP or Azure or AWS, you have access to amazing amounts of compute resources, specialized accelerated hardware, cost-effective, pay-as-you-go on demand, or you can even make, resource reservations if you want guaranteed compute and storage resources. Data storage, like S3, for example, or cloud, Google Cloud Storage, you can store petabytes of data, unlimited amounts of data. The cloud also facilitates collaboration because now you have a global infrastructure. So you can have teams in different areas accessing a data set in the US or in Europe or in Asia. And of course, the ecosystem of AI development and deployment tools that are available by the different cloud providers. For example, for AWS, I'm sure you've heard of SageMaker, and the recently launched Amazon Bedrock, which helps with LLM development, large language model development, and generative AI. Next, please. And this is just a quick, quick example here that sort of like reflects the scale that we're dealing with here. So for ChatGPT 4, I don't think this is for Turbo. I think it's just ChatGPT. For training, it was trained on 1.76 trillion parameters. This is not an open source model. And it's claimed that they have used 5,000 NVIDIA A100 GPUs, and those are very high-end GPUs, and they train continuously for 90 to 100 days. And again, based on hearsay, but yeah, the numbers look actually quite realistic compared to some of the other models where the authors basically have announced the resources that it took them to develop. And there is, by the way, a linear relationship. So what's nice about LLMs is that there's actually a linear relationship. Unlike other models where after, you throw in enough, more compute power, you throw in, more data, and at some point, it's kind of like taper off. That doesn't seem to be the case with LLMs today. So the more data you throw at a model to train it, the more GPU power, actually, we are seeing a linear relationship. So the only reason today we haven't hit that plateau is that because no one has reached that plateau yet. Now, we might come up with more efficient models, basically where the relationship is no longer linear, but maybe something that is more cost effective. But that has yet to be seen. It could be out there in some academic papers, but we have not seen it at a commercial level. So again, we're focusing on LLMs in two categories: text to image, as well as chat-oriented or text-to-text oriented models. So for text to image, we have I think probably the most famous models. We have AI Stability AI Stable Diffusion, and then we have DALL-E from OpenAI, and then we have I think we have I forget what was Microsoft's text to image, and then of course you have Apple that's working on its own, and then you have Facebook or Meta that's working on its own text to image models, and some are already moving into text to video. So what are these used for? Many uses. You have visual content creation, educational visuals, customer interactions, medical illustrations, storytelling and art, game and medical. And this is basically not a comprehensive list of things that text or image have been used for. Other folks are inventing new use cases, on an ongoing basis. Now, for LLMs, of course, we have language translation and the different models excel at some languages, others don't. So you have to probably do testing. Educational tools, customer service. So now we are seeing actually drive-throughs that are relying on LLMs to capture customer orders. And we're seeing, call centers where, the initial, I would say, the initial 10 or 20% of the most commonly asked questions by customers are answered by these chatbots. Now, some of you might say, well, that existed before in the past. True, but now we are seeing a level of sophistication, and that translates into fewer customer frustration incidents. In the past, some of those, customer support chatbots were just so simplistic that, the level of frustrations was quite high. Not with these modern LLMs. Now you can actually have a meaningful conversation with LLM. If you tried some of those, microphone-enabled LLM apps like ChatGPT and some of the others, it's actually quite impressive, how these LLMs can have meaningful conversations, unlike Siri or Alexa, or who are okay with common, most frequently performed tasks, like to-do lists and playing music and turning IoT appliances on and off. Now we're actually seeing a greater degree of sophistication. Of course, data analysis, programming aids, entertainment and media, and legal sector, and the healthcare sector. And this is, again, not a comprehensive list. Next, please. So how do LLMs and text-to-image models compare? That's actually quite tricky. That's simply because every company, every author, every creator is constantly, training their models, constantly releasing new updates. So while ChatGPT 4 Turbo continues to be the leading LLM, other providers or other models are constantly, again, sort of like competing for fourth or fifth place. And the way they're doing it, again, remember we said it's a linear process. They just train their models with more data. They use more GPUs. They train for a longer time, and chances are they will get a better model, but that might change. So again, there could be, like I said, could be just one academic paper away from seeing a fundamental change in how these LLMs are trained. So some of those leaderboards, and let me actually, Miles, can I share my screen, or is that going to be problematic just for a while? Okay, thanks. So let me just show you some of those. Okay, so here, for example, there's a website. This is the Accubits. And again, sometimes those websites, continue to be up to date. Sometimes they sort of lag behind. And the other challenge is, of course, the algorithms that they use to sort of compare these different LLMs. And those algorithms can actually, give one LLM a lead in one benchmark, but then, using a different benchmark, a different LLM might basically capture that lead. This is one of those websites that actually performs updates on LLMs, and it assigns scores, and they explain their methodology. Okay, and I think some of them only concern themselves with open source, like this website. They only concern themselves with open source. That's why you don't see ChatGPT. Sometimes they're comprehensive, sometimes they are not. For example, here I don't see Falcon. Falcon actually is one of the best open source LLMs, but I do not see it unless they have a different acronym for it. But yeah, so let me try another one here quickly before I return. Okay. The most popular one is by Hugging Face. Make sure but yeah. So Hugging Face has also this leaderboard, and it's far more comprehensive. With you can fine tune your search, and again, they explain to you so you can pick which algorithms that you want to use to basically to rank the LLMs. So they do actually a pretty decent job. So I've posted the links in the slides. Okay, back to you, Miles. Thank you. So again, you have leaderboards. Then you know what matters also when you compare LLMs and text to image models or diffusion models is of course the support ecosystem. So you might have access to an incredibly performant LLM, but if it's not documented, if you don't know how to invoke it, if you don't know how to to refine it, if you don't know how to basically gauge its effectiveness, then the question becomes, is it worth investing in it? Is it worth developing your generative AI ecosystem around it or not? The other question, open source versus private, okay, versus commercial. Then you have constantly changing performance. So the fact that authors constantly update their LLMs, their models, that means you have to just keep an eye on those benchmarks because they will change. As of today, there is no standard for benchmarking, but that's fine. You can pick the benchmark that works for you, but ultimately, you definitely have to do your own internal testing to determine which model works best for you. Next, please. So key skills for generative AI engineers. You're all sold. I mean, you're here because you're sold on this generative AI. So what do I need to do to get from point A to point B? From someone who's interested in generative AI to someone who can actually who has the skills to be involved in one or more aspects of the development pipeline, development and deployment pipeline. So first, let's go through the classic. Let's go through the classic ML AI pipeline. The classic ML AI pipeline involves the usual data collection, data collection, data cleaning, preprocessing, exploratory data analysis, and so on and so forth. And for each one of those, there could be one or more tools, some open source, some not open source, depending on your company's preference. Sometimes a single tool will cover multiple stages. Okay. Now, generative AI has a slightly different pipeline that's actually can be merged with the classic AI pipeline, just because most of the development efforts that we have seen so far, at least the ones that we know about, involve pre-trained models. So whether you're doing text to image, with like Stability AI, Stable Diffusion, you are using a pre-trained model, a model that you can download from Hugging Face, for example. You can download variations on this model. You can download refinements that run on top of those models. So most customers today start with what's called a foundation model, and then they basically work with it to make it specialized. So making a model specialized, aka fine-tuning a foundation model, is now actually a key task in the pipeline of generative AI. And many tools are now popping up, whether cloud-based or open source that you can download on your local computer. So we are starting to see tools that are focused primarily on generative AI development. Some of those tasks are like prompt engineering, or prompt design. I think most of you have heard of those. So actually, this has becoming a field of specialty. But will this, skill remain with us a year or 2 or 3 from now? We don't know. We don't know. Model evaluation and testing, that's a big issue. We're testing for performance, but we're also testing for things that are really, really important, such as, bias. The issue of ethics with LLMs is now, at the forefront of the issues that are being discussed. Fairness, is that model basically using data that it's supposed to? Is it generating data that it's supposed to generate? So lots of tools, lots of methodologies are actually focusing on model evaluation and testing. So when we say model evaluation and testing, we're not just talking about metrics of accuracy, speed, and so on and so forth. Thousands of LLM is a good strategy to learn GenAI. Okay, we're going to get to that. So deployment and scaling. And of course, once you're done, how to deploy your fine-tuned LLMs, how to deploy the APIs, and which services are available to you today to help you, of course, with the deployment and to scale, as your application succeeds. Many of the LLMs today, by the way, the commercial LLMs are actually, made available to us as SaaS. So now we're actually seeing, ChatGPT, if you can think of it as a SaaS, you too can deploy your LLMs in the future, or fine-tune LLM as a SaaS or diffusion model. And of course, goes without saying, monitoring, which includes drift detection, performance, and so on. Next slide, please. So these are some of the key skills. So that hopefully answers the question. You really need the foundational skills. There is no escaping. There is no escaping having the foundational skills that goes with machine learning, whether it's classic machine learning, whether it's, generative. So some of those foundational skills, and this is a subset, by the way, some of the tools can vary. You have Python. If you're dealing with tabular data, SQL is still relevant, not in all disciplines. Like if you're dealing with text to image, chances are you may not run into any algorithms that require SQL. Pandas, very key tool. NumPy, are all the foundation models proprietary? No, absolutely not. Some of them are proprietary. Many of them are open source. Some good ones are actually open source that you can just download. And they have different licenses. Some have MIT, some have Apache, XYZ. So you just have to read the license carefully. Like Facebook, I think, or Meta, they provide their models, but you can't use it, I think, like for commercial, or like certain restrictions on commercial use. Others basically open source, like Stability AI, their models are open source, and you can download them, do whatever you want, including creating commercial applications. Are there any other questions that I've missed? Let's see, let me open.
Yeah, there's a question about why would somebody provide an open source LLM? Like how do they make money doing that?
Well, the same way companies like Firefox and companies like Spark and the whole Apache ecosystem, hopefully you'll go to them for additional support for customization. This is how many open source providers actually make money. Elasticache and so on. At some point, maybe you're a Fortune 500 company, or maybe you're a public sector project, and you may need some training, customization, tweaking, whatever. Yeah, this is how you would make money out of it. You actually would reach out to them for specialized applications. Other than that, yeah, the best marketing actually is open source tools. This is how your customers can see how powerful your models are. And I am sure that providers or authors like Stability AI, I'm sure they have their own internal models that they have not released. And I'm with 90% certainty, not every author of LLM has released all their models. I think, I'm sure they have like some internal models that they're not ready to release to the public, or they may never release to the public. So what is the incentive for companies to, okay, got it. Is it true that most of the DLML positions, even engineering ones? No, not really. As a matter of fact, many companies will tell you PhD or equivalent experience. To be honest, I have never ran into a situation, or any of my friends ran into a situation where, let's say, if they can demonstrate, if they have a portfolio of projects, let's say in GitHub, they were ever turned down, just because you don't have a degree. The overwhelming majority of employers will actually look at your work portfolio, your GitHub, your projects, and so on and so forth. Did I miss anything? They actually collect data, and yeah, they can actually collect data. That's true. Data is money. That's very important. Like if you're that's a good point. So if you are, open AI, of course, nowadays they give you a choice. If you don't want them to collect data, you can pay for the model. You can have a subscription. And they will give you, like, I think ChatGPT Enterprise has a plan for companies. Because remember, one of the concerns is that, the companies are worried about today is that, I don't want to share. What if my employees start posting proprietary code or proprietary content into, let's say, ChatGPT or Bard or Copilot? That's why many companies would rather bring their own LLMs in-house and train them and customize them, because they don't want their employees to use those, publicly accessible LLMs. And then, of course, whatever proprietary data gets collected by OpenAI or Google. I'm not suggesting that's what they do, but you never know. So some of the tools, again, LangChain. So this is a tool that basically allows you to sort of like chain LLM models. TensorFlow, PyTorch, sklearn, Seaborn. So really, really basic libraries. And ExitCertified and WebAge and Excel, they offer workshops that can get you up and running with these skills. Next slide, please. GenAI tooling. Now, the previous slide was really mostly geared towards, let's say, classic ML, and those are really necessary skills. Beyond that, then you have, of course, portals, and this is where basically things get interesting. Today, you have, many of the cloud providers are trying to basically sort of like move in on the territory of Hugging Face by creating their own portals to facilitate, generative AI development. You have, Azure, GCP, and so on and so forth. But Hugging Face today is still one of the largest hubs for generative AI tooling. I'm going to share my screen, Miles. Is that okay? Oh, are we running out of time?
Go ahead.
Okay, so let me, where's my screen? Hugging Face, yeah, just very quickly. So Hugging Face, can you see it?
Yes.
So this is today your go-to hub for your LLM needs. It has literally thousands of models. Of course, you have to pick models from names that you trust. You have Stability AI, you have Microsoft, you have all these. You have Meta, OpenAI, and so on and so forth. And you can look for the category of interest to you. If they are on Hugging Face, they are available to you for download. So, for example, I can go to Stability AI, and Stability AI has multiple models. It's one of the big names in text to image. And then you can go here and can say, okay, I want, let's say, show me all of your models. So you have Stable LM, all these models, expand collection. Then you can go to the model of interest, and you can say, let's see, Stable Diffusion, that's a popular one. Oh, this is a portal. Sorry, this is, okay, let me try this one. Yeah, let's just click on this guy. So here you have files, and these are the models that you can download. Some of them are quite massive, by the way. Model card gives you like an overview of this model, maybe some papers, some performance information, comparisons, okay, and so on and so forth. So they have also data sets, very popular data sets, 99,000 data set to train. So if you want to basically do fine tuning, or if you want to basically experiment with building your LLM, hopefully it's a small scale LLM, because unless you have GPUs, it's hard to basically train large scale models. Some discussion groups, documentation, training, solution, and some additional paid services, of course. Back to you, Miles. Next slide. So why NVIDIA? Well, NVIDIA has been with us for quite a long time. They actually started building GPUs, like I said, for gaming, rendering, and so on and so forth. But then, developers in the space of, let's say, in the field of matrix multiplications, scientific research, discovered that, parallel processing that's available through GPUs can actually be quite helpful in performing parallel calculations. And many of the ML tasks actually can be parallelized. As a matter of fact, many models today are developed with GPU and parallelization in mind from the get-go. There are some pretty sophisticated AI models, but they're quite useless, believe it or not, just because it takes forever to train them. They're very expensive. So you'll be surprised to what extent hardware plays a role in actually architecting AI models today. Next slide, please. All righty. Miles, all yours.
Oh, I thought maybe you'd talk a little bit about the first couple of these.
Yeah, awesome. Yeah. So let's see. So So NVIDIA, being a leader in training AI models, now actually has sort of like matured its offering. So NVIDIA today has a massive AI ecosystem of support in terms of hardware, in terms of software, in terms of libraries. And so they also started basically helping folks upskill, because everything today, for the most part, when it comes to AI, I would say 2/3, if not more, of AI training actually takes place on top of NVIDIA. GPUs using NVIDIA's standard libraries like CUDA and so on and so forth. So it's quite important to actually learn not just how to work with models, train models at a high level, but to also know what's involved at the low level, at the hardware level, because this is how you can basically tweak maximum performance out of your hardware, because everything today is tied to your training infrastructure, and how effectively your training process can leverage your infrastructure, GPU infrastructure. So fundamentals of deep learning, it will basically give you the foundation, so you can use TensorFlow. It will teach you how to basically build basic models, how to perform data preprocessing, and how to evolve from simple models all the way to, I would say, production grade models. So it's a wonderful introduction. And of course, you get a certificate if you pass the assessment with it from NVIDIA. A really nice introduction to deep learning. Next one. Now, oops, I thought I changed that. Okay, so we said it's very important to understand how your code interacts with GPU. Probably the most popular library for I would say machine learning is CUDA by NVIDIA. So this is the interface layer, or the driver, that you can basically make calls to from your Python application or C++ or whatever, that basically allows you to maximize the performance of your GPU infrastructure. But there's much more than just CUDA. Next slide. Now, once you sort of like once you master the fundamentals, okay, the classic ML, neural networks, convolutional networks, DLLs, then you move on to, depending on your area of interest, we're seeing demand for generative AI with diffusion models. That's what we're seeing. So with this workshop, basically you actually, this is really a nuts and bolts and math and Python. This is one of my favorite workshops, by the way. I mean, you literally understand the math, then you apply it with Python and PyTorch and Clip, and you progressively build models throughout this one-day workshop, where you understand the fundamentals of diffusion, generative AI with diffusion, and then you progressively work across 4 or 5 labs until at the end you have full mastery of the math and the code behind one of the most popular, diffusion models. Really, really powerful. This is my favorite, actually, workshop. All righty.
So, yeah, there's a number of one-day NVIDIA workshops. Outside of that, when it comes to developing and deploying your models, that's generally where the cloud comes in, right? And when you are ready to explore, to experiment, to take it to the next step, initially you can fire up a Jupyter notebook. You can experiment with the labs using Jupyter notebook. But at some point you wish to move to the next step. Does NVIDIA has cloud-based? They have their own cloud. They have their own specialized data centers. Yes, they do, actually. And there's actually also a certificate and an exam in that area. Yes, thank you. So, for example, I'm using AWS as an example, but Azure and GCP, they have their own tooling. For example, AWS released Amazon Bedrock, and Amazon Bedrock is a really nice hub. Can I share quickly? Do we have like a minute to share? Well, not much, no.
Okay, okay. Let's skip it then. But yeah, I mean, you can access, you can get a free tier access to AWS and go visit Amazon Bedrock service. Really amazing service. It just simplifies the process of developing and deploying applications using some of the more popular LLMs and generative models, including but not limited to, of course, Meta's, and Anthropic's and Amazon's own and so on and so forth. Really nice interface, but they have much more than that. They have, of course, the model registry where you can save iterations of your model. They have, of course, the SageMaker Studio Labs, where you can basically, it's almost like a fancy Jupyter or Cloud Node Jupyter environment where you can collaborate with team members. And you have lake formation and glue for ETL and data lake. So if you're going to be basically working with different data sets, then you want to save that data in an organized and meaningful way. Okay.
So somebody had asked, how do we find all these classes? Well, basically, each of the three sister companies under Excel have their own website, and I included here. We'll throw some examples in from ExitCertified, but if you're not quite there on the Python part, if you're brand new to Python, that is the language that is mostly used. You can take a very low-level intro, but if you're somewhat familiar with Python and you just need to learn some of those libraries like pandas and some of the basic concepts around data science, we have courses around that, and then those will get you ready for the one-day NVIDIA classes. And the one main class we normally get into is the fundamentals of deep learning. And then from there, you might go to the generative AI with diffusion models. We have dates for those coming up February 26th and 27th. But if you want to see all of our stuff, just go to exitcertified.com/NVIDIA, and I'll bring that up and show you what that looks like. And we have a few things in here. Obviously, we have the classes. So if we go to Fundamentals of Deep Learning, view the course, you can see, okay, here it is, February 26th. We have live virtual 9 to 5 Eastern, right? And you can just book it right through there, or talk to your sales rep, either way. We also have this learning path document, which kind of shows, sort of a typical path through this if you want to become a Gen AI engineer. If you don't know Python, well, then you'd have to start with these sort of optional prerequisite classes. Then we've got the fundamentals of deep learning. And then from there, you can go kind of two different ways. If you want to learn about diffusion models, then you go that way. If you want to learn more about transformer-based natural language processing, you can take that course and then get further into conversational AI applications. But after that Gen AI diffusion model class, then you can start getting into the real LLM classes. So we've got rapid application development using LLMs, and then the efficient LLM customization. That's where you really get into what I would say heavy duty Gen AI, is where you're saying, these models that are built and trained on massive data sets are great, but, our data sets are a little different, and we need to use our data sets to kind of, maybe customize those models a little bit. And then we get into, model parallelism, building and deploying these LLMs, so neural networks and so on. And so this is just a subset of the classes, but this is a nice example. And so all that's available, like I said, just from that NVIDIA page. And the nice thing, like somebody says, taking a class, they're not free classes, but they give you access to these GPUs to be used in the labs. And that is a nice perk of being able to do those labs on real GPUs that you're not, paying for out of your own pocket, like that way. We also have a lot of classes on all the different cloud vendors. So, if you're interested in, probably have it from this diagram, you can see, we're partnered with all the 4 major cloud vendors. So we have all their courses. So if you're in AWS, you want to learn about SageMaker and machine learning on AWS, you can do that. And then we have all these sort of classes around it. And so down here, we're talking really about the machine learning and AI side of things. And so obviously NVIDIA, but we have some other vendors as well if you're interested in some other classes. So that's sort of what we do. I think that's the main thing I wanted to cover. We have a little bit of time for questions. Can we get the recording? Yeah, I think the sales reps are probably going to be sending that out. If you're looking for it, talk to your sales rep and they can get you this. The recording will eventually make its way onto our website. So I think that's the main goal. What what else do we want to say? Oh, varies between workshop and labs. Okay. Yeah. Yeah, the PowerPoint I may be able to actually share right now. Let me see what I can do with that. Where did we go? Yeah, let me drop a couple things right now into the chat. Just that learning path. So depending how you're using Zoom, you may or may not be able to get things out of the chat. We'll see. Some companies, they kind of block access of passing files through Zoom. So that won't work for you, but for everybody else, let me just save as.
Hey, Miles?
Yeah.
Is it possible to kind of like, post it as a PDF file on the website and share a link, or that's not a capability that we have?
Well, yeah. I don't know if we want to do that. Yeah, so that's a PDF of the full slides for those of you that can get it from there. Well, we're at time, so I think I want to thank you, Mike, for taking time to put this together.
Thank you.
And whether you come in from WebAge or Accelerate or ExitCertified, your sales rep will be able to get you some more information about those classes if you're looking for it. If you don't have a sales rep, you can always sort of just contact me, I guess, and I'll put you in touch with the right person. Let me put the my email address in here one more time, just so you have it. You can always just find it through the website and sign up for things through there. But otherwise, we wish you luck, and keep looking. We've got a series of sort of AI webinars that we've been doing the last couple of months. So however you found this one, you should be able to find our others. We had one earlier this week that was on sort of the ethics around GenAI, which is a very interesting area. These days we find that we can, the more data we have, the better these GenAI models are. But the question is, should all data that can be collected, should it be collected? There's some really interesting things around that. But yeah, thanks again, Mike. I don't see any more questions coming now. Okay, so some people, this was their very first introductory class on GenAI. Yeah, I thought we might have a mix of some people who were, so somebody asked again, how long do you have access to the GPUs? It
depends. But per lab, per workshop, I found that it's quite variable. And if there is pressure, and there is pressure, if there's lots of students, they might basically time slice it and give you a shorter slice. But it's enough from my experience. Yeah,
but for that one-day class, you get so many hours of access to do those labs?
Yeah, there are timers and it expires after a while, per lab.
Yeah, the first PDF is just the one page. The second one I uploaded is the full presentation.
But FYI, I was able to actually run those labs in Colab. So even if if you're out of time, those labs, you can download them, the Jupyter notebooks, and you can run them and keep practicing later on.
Yeah. Let me just put this.
And yes, and I will be the instructor for some of those workshops, so maybe I'll see some of you there.
Yeah, those ones in February. I think we've got you slotted for those, the 26th, 27th, right?
Yeah, so if you're interested, we have 2 workshops scheduled for February. Please sign up. That'll be fantastic if I can see some of you there. We can continue our journey.
Well, thanks all for attending, and hopefully we see you down the road.
Thank you all. Appreciate it. Thanks, Miles.